Hey all. Okay, so I'm going to make a confession that I did not make a video for Notes 1.1. Normally in past years I've tried to do it in class and we've run out of time just a little ways into it. So what I decided to do this year was just kind of talk you through some notes that are already done. In past years I've had classes just copy down notes that are filled out, but I thought I'd kind of hit a happy medium and talk you through the filled out notes as a alternative, which will maybe help you out a little bit. So this is not the way notes will typically be done, so don't panic. All right, so we're going to start with vocabulary as usual, and we've got undefined term. An undefined term is a word without a formal definition. It is so accepted that it does not need to be defined. And those undefined terms are point, line, and plane. A point, although it doesn't have a definition, we can say about it that it has no dimension. It doesn't have a length, a width, a height. When we draw a point, or when we want to represent a point in mathematics, we do it with a dot and a capital letter. And it's going to be important that you label all your geometric figures correctly. So when you're telling me a point, I expect to see a dot and a capital letter. And then we have line, our second undefined term. And a line has one dimension. It has length. It continues on indefinitely in that one direction of length, but it has no width or depth. A line is represented by a line with two arrowheads or a lowercase italicized letter. So for example, as you can see down here, I've named my line by the 2 points on the line, so A and B, and it can be in either order. It could be AB or it could be BA. And I've got the little line above it, and it's got two arrowheads on each side. The other way to name it is by calling this line L, and you'll notice that L is a lowercase letter, it's italicized, and is not associated with a point. And then we know that through any 2 points, there is exactly one line. So any 2 points in the entire universe, if they exist, then there is one line between them, regardless of whether or not you can see the line, whether it's drawn. And we can use any 2 points on a line to name it. So as I said before, this line up here, it could either be AB, it could be BA, or it could be named by additional points if they were shown. All right, and then our third undefined term is a plane. And a plane has two dimensions. It has length and width, but no depth. And it continues on indefinitely in those two dimensions. So we represent it by a parallelogram, but the plane is not limited to the boundaries of that parallelogram, right? It continues on out here forever. And we name a plane using 3 non-collinear points. Non-collinear, non means not. Collinear means on the same line. So 3 points that are not all on the same line. And through any 3 points that are not on the same line, there is exactly one plane. And we can use those 3 points. So we could call this plane up here plane ABC. Notice how these each have a dot and a capital letter. So those are my 3 points. Or the other way to name a plane is to find a capital letter not associated with a point. So example, M up here, and then we could call this plane M. And those are my 3 undefined terms, point, line, and plane. All right, we already talked about what non-collinear was, so now we're going to talk about collinear. Collinear obviously is points on the same line. Coplanar, therefore, is points on the same plane. And defined terms are terms that can be defined using known terms. All right, we're also going to talk about line segments and endpoints. Line segments are the part of the line consisting of 2 points known as endpoints and all of the points on the line in between. And when we write a line segment, we use those 2 endpoints and we have a line above it, but notice now my 2 arrowheads are missing. And again, the order doesn't matter, AB or BA. And then a ray consists of an endpoint and all the points in one direction on that ray. So if I look down here at these 2 rays, this first ray is BA. Notice I start with the endpoint B, and then all the points that are on the same side of A as A, and my line is drawn from B, my arrow is drawn from B, and then I have an arrowhead in the direction of A. And then this ray down here is ray AB. Starts with endpoint A, moves over to B, and it's all the points on the same side of A as B. And notice that my arrow is now pointing in the direction of B. These are 2 different rays. These are not the same ray. Then we have these things called opposite rays. For something to be opposite, or for 2 rays to be opposite rays, they have to be collinear, so they have to be on the same line. They have to have the same endpoint, and then they have to point in opposite directions. So if I look down here at this example, my two opposite rays are ray BA, which is the ray that starts at B and goes through A and beyond, and ray BC. All right, they are on the same line, so they're collinear. They have that same endpoint B, but they point in opposite directions. And then an intersection is simply the set of all points that two or more geometric figures have in common. So two lines can intersect, two rays can intersect, two planes can intersect, right? All kinds of things can intersect. Any of the points that those two geometric figures have in common is known as their intersection. All right, and then these notes just basically run through kind of naming examples. So if we have to look up here at line LN, here's line LN right here. I can either call it by any 2 points on the line, so LM, ML, MN, and M, or I can call it line B because it's got this italicized lowercase b associated with it. All right, 3 points that are collinear lying on the same line, L, M, and N lie on the same line. 4 points that are coplanar. All right, so I can see my plane here. So L, M, N, and then point P here is also in my plane. And then if I look, see A and B here, those are not points. Those are naming these two lines right here. And then Z over here, it doesn't have a dot, so it is not associated with a point either, although it could name this plane. All right, and so we got lines and planes in the figures that are not drawn. So any 2 points in the plane make a line. So for example, QL, right? It's 2 points, automatically there is a line drawn between them. And so that's what all of these are. They are naming those lines. And then if we named a plane that is not drawn, LMQ is a plane, right? I have 3 non-collinear points, therefore there is a plane. All right, another name for segment AD, because that is what this represents, is DA. They've got to have the same endpoints if it's a segment. So that's the only optional or other name for AD. And then rays with endpoint F. Well, here's F. F is the intersection of these two lines. And so all of the rays that start with F. So FA, FB, FD, and FC. And then my opposite rays, well, FA and FD are opposite rays because they are collinear, and FC and FB are opposite rays because they are collinear. Okay, and then this question asks, are CF and CB the same rays? Well, they both have endpoint C, and they both go in this direction forever. So yes, those are the same rays. FC and BC, no, because they have different endpoints. One has endpoint B, one has endpoint F. All right, so if you're going to sketch a plane and a line that intersects at more than 1 point, and we're going to be drawing some stuff tomorrow, so don't panic if you are having a little trouble with this tonight. We draw our plane like a parallelogram. We draw our line. If it's going to intersect at more than 1 point, the line has to lie in the plane. And so I've drawn it, and I've given it a description so that you guys can see more what I'm talking about, and I would appreciate if when I ask you to draw stuff, if you would do the same thing. So line L here, it lies in plane P, intersecting it at every point. And then we want to sketch a plane and a line that is in the plane. So I drew the same thing as I drew before. And then I need to sketch another line that intersects the line in the plane at a point. Well, if it's going to intersect at a point, it should go through my plane. So I've drawn this dashed line here indicating that this red line shoots through my plane, intersects this point. So this part is below the plane. This part is above the plane. Imagine if you stuck a pencil through a piece of paper. And then I've written a description of that. All right. And now the intersection of two planes. So I've drawn my first plane as if I were facing it. And then I've drawn the second plane, plane N, as if it were like a tabletop. And the intersection of two planes is a line. At the intersection of two planes is always a line, and so I've drawn line L here as the line of intersection. And you can see I put a dashed line right here to indicate where plane N is behind plane P. All right, here I've drawn a plane again, and I've got two lines that intersect at different points. One intersects at point A, one intersects at point B. Over here, looking at this figure, I need to name the intersection of line MX, which is this line right here, and line A, which is right here. Well, they clearly intersect at point M. Plane C is my shaded plane. Plane D is my unshaded plane. And the intersection of those two is line A. And that concludes Notes 1.1. If you've already done 1.23, fantastic. If not, go do them now. Any questions you have, be sure to ask at the start of class. Thanks.